Hey everybody, it's Marty, the JavaScript party, and my buddy Rhett. We are just chilling, writing some code before work. It's 8:22 a.m. It's 43 degrees outside. The rain has finally stopped, and yeah, everything looks pretty good. It's blue skies. It's a little damp outside, not too bad. It's kind of funny. For the longest time, I would be like, "Oh, okay, it's X number of degrees outside. Let me go outside." And then sometimes like 55 degrees would feel colder than like 38 degrees. And I finally over time I've started to suspect that what happens is if it's 55 degrees and getting colder, you'll start to see you'll feel a lot colder than and then if it's 38 degrees and getting warmer, you'll feel a lot warmer than 38 degrees. Like not only do we have a pretty good sense of the actual temperature. I think we have a pretty good sense of the direction the temperature is going in. So that's kind of neat. Most people have always chalked that sort of how how different temperatures will feel different, up to like the humidity, or they'll not chalk it up to the wind. Like how much wind is happening. But I do think that when it's getting warmer, it seems to feel warmer than it is, and when it's getting colder, it seems to feel colder than it is. So, anyways, now when I first got this up and running this morning in preparation to make this video, I was just like blown away at how cool this is. It is just really really cool. I'm really really happy with how that looks. It's just a nice place to be. Um, Ooh. But anyways, we are trying to we're having a problem with code coverage. Let me get that code coverage going. Um, so, and then I guess because we have this FIT that tells it to focus and only run this one test, and we're trying to get it to run um, inside of, let's see, this is the animation service. Nope, animation service. And all that. So I guess this is kind of confusing. So let's go ahead and let's just not run this. Let's do this, and then we'll comment out this test that fails. So we kind of come back up to speed again. Okay, so now it's running. I haven't quite seen the pattern yet of when it decides to run and not run. But yeah, so there's where we are, and we're trying to get this guy here. We're trying to figure out why we can't get this to run. So what we did was we call the visualization. So I'm just going to put that back. And then I'm going to undo this expect. That was a weird result. So it'll start failing again. But basically what happens is we call this function we get the original hash value, and we expect it to be nothing because it has never been initialized at all. It's never been executed. So it runs that hash value, it gets nothing back, and that's good. And that's what we see. So when I changed this, it didn't actually run. And I would like to understand this, but if I come over here and hit refresh, I've learned that then it'll actually run. I see now we're failing, which is what we expect. And we're still not getting this to run. And what we figured out was, as I was digging in, I was like, oh, okay, when we call this visualization service hash, so when we say reset hash, when we call reset hash, and we give it a number, we expect the hash to get reset. So let me go into that. I think go into definition. Yeah. So we're kind of expecting this to get reset. Let's see. Um, so reset hash gets a number and a height, and then it goes through the data. Okay, yeah, and then we get down here, it creates a hash string, and then it runs this get hash string, and then it hits the then. And so since that then happens, that means that what happened was, like, if you can try to visualize it, what happens is it runs this line of code, it runs this line of code, it runs this line of code, runs this line of code. It gets to that then for the promise that we saw. So let me hit this little forward button. Yeah. It gets to this line of code right here. It runs, gets to this line of code. And then what it does is it defers this. It says, oh, okay, we are no longer synchronous. We've just gone into asynchronous mode. So I'm going to defer this for the future. And so the way it's always been described to me, and the way I've always seen this described, is that every computing cycle, there's a set of code in JavaScript. It goes through this loop, and it gets to the very beginning, and it gets all the new work to do, and it has a set of code that it's supposed to run. And then when it runs a line of code, it may find more code to run. So then it'll run the code that it finds. And then when it gets all the way to the end, as far as it can go, it goes to the next line, runs that, goes to the next line, runs that, right, until it's all done. And then it waits till the very next line and it does the whole thing again. And it runs all the synchronous code. Well, when it sees a then, what it does is it puts it, whether this returns something immediately or not, it goes and it puts it at the beginning of the next cycle. So that's why we got to this hash end before here's the new hash, right? So if we look at so we see hello, hash start, hash end, all done. And then here's the new hash, bro, right? So this happened way after this. And that's because this got pushed to the next thing. And I was trying to think through why that would be. And I think it's because this get hash string probably, if at all possible, will want to use your math coprocessor to create the hash, because a math coprocessor would be able to do that a lot faster. So it kind of sends that work, if possible, it sends that work off to your math coprocessor, and it'll do that work in parallel while this is going on. So it'll literally run at the exact same time, but it's on basically a different computer that's basically completely set up for doing math. The architecture to do math at the metal level, at the silicon level, where things are moving in registers and things like that. That the way you set those things up there are better ways to do math than to do like logic, and to do to do for loops and do like if-then statements and assignments. That architecture for something to do stuff like that, you can do things like doing math calculations in a different architecture a lot faster. So a lot of computers come with a different math coprocessor. So this then will get sent off to the math coprocessor. And so checking with the math coprocessor to see if it's done gets put to the next cycle. Now, it is possible you don't have a math coprocessor, and then it has to figure it itself out. So technically, in that case, it's a synchronous call, but it doesn't matter. The minute it sees this then, it says, okay, we're going to check on this when we come back at the beginning of the next cycle. Now, the thing to keep in mind, there's one more little sort of thing to imagine, and that's that can happen thousands of times a second, maybe even tens of thousands of times a second. But screen itself is only updated once. It attempts to update that 60 times a second. So one thing is happening thousands of times a second. So the better and better your computer gets, the more of those cycles per second your computer to do. But no matter how fast your computer ever gets, it won't try to update the screen faster than 60 times a second. I believe there are some cards, video systems that will update faster than that, but like 30 for gaming and stuff like that. But that's like, I think, a whole different, just entire different reality than what we're operating in. But anyway, so what we have shown is that this is not going to happen before, right? So let's just, when we go, we see the hello world happen, then we see hash start, get console logged, and then we see our hash string, and then we see our hash end. See, so then it hops over to hash end, and then we get all done. So now the test is completely done because that came from the spec. I don't know if this is the right one. Yeah, that's not the right spec. I think I need to go back twice to get to my spec. We get to the all done, and then after it's done the evaluation to check the hash and everything, we get, here's our new hash. See, so what we need is for it to wait. And so we learned, I believe it was on Sunday, that you can actually get it to wait. And we did that in, I believe, in our app component spec. Yeah, and we did that by calling this fakeAsync thing and then telling it to emulate like a 1 second wait, and then it would do this test. So I think that is probably the state of the art way to do it today, and it has been for a little while. I probably won't stay that way forever, but anyways. But that's how we're supposed to do it today, and so that's just the reality that things change, and at the moment this is how we do this. So we are in animation spec. So our problem is in visualization service, but we are working in animation, so it's easy to get that kind of stuff mixed up in your head. But anyway, so we need to import those things from our test, and I think this is where we should put that import. And then basically I think we need to wrap this code, this whole thing, inside of a fake async. I think that's what we did. So let's go back to our app component spec. Yeah, see, we basically have this function. It's called fake async, and we say, hey, fake async, and we wrap it. We wrap our function, our actual test function, in there. Now, what that does, I don't know. We could probably interact with ChatGTP and find out exactly what it's doing, but it's just not something. Now, I do know, I used to think that what we're doing by passing this, I believe on Saturday or Sunday, I thought that when we passed a function into another function like this, that was called currying. But I learned that is not true. That is actually called a callback. So, it was just kind of one of those words that I'm 99% sure that it is a very common misperception that passing a function to another function to be called is currying. And then it wouldn't even be 100%. It wouldn't 100% surprise me to find out that, oh, well, no, that is a form of currying or something like that. But anyways, at this point in my mindset, this function in here is our callback. This is a function that I want it to call whenever this does its thing. So this alone won't solve our problem, I'm pretty sure. And see, seems like it should have just automatically, the watch should have called at that point, but apparently that only watches the code. It doesn't watch the tests. Okay. And we're still going to have a problem, but it's still zero. Uh, it's still wrong. Like we didn't get a new hash. Now I believe, and I'm just going to try to do this out of memory, that now we want to say tick. And this will told it to emulate a 1 second wait. I don't think it won't actually do a 1 second wait. Or at least I hope it doesn't actually do a 1 second wait. But emulate a 1 second wait. Because the problem is this, you will start adding these seconds in here, and next thing you know, your unit tests take hours to run. So it still didn't work, right? We still did not get our new thing. And maybe okay, I think I should put the tick between the service and the assignment. So we reset it, but we need to wait for it to be done, and then we need to do the assignment, and then we can check our assignment. So I'm hoping it's something different. Nope, that didn't work either. That's very disappointing. And let's see. So it didn't wait. I mean, it like, okay, so in this thing, yeah, so that's very disappointed. Let's see what our hash is at this point. Just make sure that the hash is actually being reset at least. Yeah, see, this is our hash, and we want this hash. We want to get this hash string. We want to this visualization hash value to be, but see, we don't want to do this test here. We don't want it to get to all done until after this promise happens. And I thought that this tick 1000 would cause it to wait for like to sort of emulate a wait. So I'm just going to do this. This is not what I want to do. I want to definitely figure out a cleaner way to do this. And by cleaner, I don't mean that this is dirty. A more emotionally acceptable way to do this. I believe I can move this into here. And then what will happen, I believe it will be done when it gets back. I'm not 100% sure on that. But, nope, it did not. Let's see. And I guess what we really want to watch is this. When these... Here's the new hash, bro. All done. Let's have it wait a whole second. So it should wait literally an actual physical second before that test is done now. See, we still get to all done before. This kind of makes me think that I'm doing something completely wrong. Let me put question marks there. Just make sure that the new code is running. See, yeah, it does. I think it feels like it's definitely slower. But it's weird because this still... So let's make it wait like something that will be very, very noticeable. So 3 seconds should feel like an eternity. Yeah, see, felt like it was forever. But it's weird because that still didn't call. This is interesting. So obviously I fully do not understand something. Okay, so I call the reset hash. Right, so I call this function, but it absolutely refuses to return from this call.
You ready?
It refuses to run that call before the test is done. And I don't really understand why. Because it literally waited 3 seconds. Right? So like if let's try to, I'm just going to put this on a different screen, off screen so we can watch this. So what I'm trying to watch is this and see what happens. Reload. So like nothing happened. Let's see, animation, set hash. Then wait a whole, oh my, okay, then wait 3 seconds and then call. Oh, wait. Oh my gosh. You silly, silly, silly rabbit. I'm actually still assigning it before. Why didn't you tell me? Just kidding. But it's still screwed up. And I guess I should have known it was still screwed up because it's still getting to this all done before it's getting to this promise call return. That is fascinating. So definitely have some sort of just absolute misunderstanding here. Because this should call and then, but I wonder if, I'm curious if that actually slows things down in real life or not. No. Okay, so that's good to know. But it's so no, even if I make this like a 10-second wait, 10,000. What time is it? Okay. 3, 4. Oh, so it didn't wait 10 seconds. So because that was definitely not 10 seconds. 10 seconds. And then reload. Oh. So that time it changed when I changed the... So that was nowhere near 10 seconds. 1, 2, 3. So that's another thing that is not working at all like what I thought it worked like. Oh wait, when delay is larger than... Well, that's interesting. So I've never seen that before. So when a delay is larger than or less than 1, the delay will be set to 1. Non-delays are truncated with an integer. Well, that is interesting. So that is weird. I've never noticed that before. So delay is larger. But I think, I wonder if, yeah. Oh, so that's interesting. So that's why 0 works, because it sets it to 1. I've never seen that before, but I don't think 10,000 is definitely less than 240 billion or whatever that 14 billion. Yeah, I'm pretty befuddled here on why the set timeout isn't working. Let's see if ChatGPT can help. Oh, but there's a problem with using set. There's a problem with using set timeout inside a fake async zone without calling tick for that specific delay. Set timeout will not run unless you simulate the passage of. Okay, so let's see. So it doesn't want. It says I should just do. Okay, fade with simple timers. So it's saying just do this, but I don't think that's working either. Basically, just do this. Two things. I need to do the two things. But I don't think that's working for us either. See this here is the new hash. Problem. That within reset hash. There is a promise. And that promise won't execute until after the test is over. 50. This is kind of like, it kind of reminds me of like, where you're supposed to say like a magic word at a door or something like that, and then flush micro tasks. That'd be so funny if this works. It'll be also funny if it doesn't work, right? Like it's going to be funny either way. And the only reason it's funny is because I'm not, I don't have a time thing, right? Like we're just having fun right now. And I will say that having fun is so important. Like I'm gonna have a pretty rough day today at work, right? Like we're in a weird place at work, and it's gonna be hard. And coding is not probably gonna be fun, but I'm having fun now. So then that sort of in my mind will sort of counteract the not fun part of work. Okay, so was I supposed to, where was I supposed to do the, yeah, so I did that right. I think it's still, oh, I have all the way down here. Yeah, it still did it though. It still didn't run. The flush micro test thing didn't do it. Did that go before or after? Maybe it would. No. first resolve it and then tick it. So it says run this, then run flush micro tasks, and then run. I'm just going to run it again. Let's come back over here. And then still not running. Let's change this to 2 just to make sure we're actually getting new code. Yeah, equals to 2. It's still not doing it. Time tick ms. Oh, flush. Did they use flush? Okay, so it actually kind of cracks me up that it didn't work. You know, that's sort of the ups and downs of developing code in the modern day, is you just get these ups and downs. Still solved after the test. And I do like this because it is teaching me to write. Oh, so I guess I should tell it what's inside of reset hash. I wonder if it's the console logs that are screwing things up. So okay, so I didn't quite understand that. I don't think I have time. So it's saying that, okay, so let's go back. So it's saying I don't need to do this at all. Okay, so this is basically the same thing, I think, as this, but I guess fine. I'll move it to this. Maybe there's something funky about it. I don't know where that M came from. It must have came from before. Okay. And I'm going to have to bail at this point. Yeah, it's still calling after. Oh, but here's the catch. If what does get hash string look like? Let's go back over here. Oh, Oh, so this might be my problem. We'll just do this. But there's an important bit. There we go. So fake async doesn't work with native rated browsers like Crypto API. Okay. So that is interesting. And I think this was a huge level up. I did not know that. There was no way to know that. And man, this is. So I definitely need to read over this when I have more time. Unfortunately, it is. Oh my God, I got 2 minutes to go to work. Bye.